So today we're going to be looking at square roots and taking that further than we have in the past. So before we've done things like the square root of 100, and we've said that equals 10 because 10 times 10 is 100. And we've done the square root of x squared, and we said that is x because x times x equals x squared. So we've talked about what that means, and we're going to take that a step further. So let's see. We're going to look at, okay, so here we have a radical, and we're going to look at some vocabulary. So first we have the radical sign, also known as the square root sign. You've probably called it some different things, but this is the actual symbol. Then we have what we call the radicand, and that is whatever is inside of the square root sign or the radical sign is called the radicand. And then we have the index, and the index is the little number on the outside. Now, in the past, you have always had that number be 2. So ever since you've ever done any math, it's assumed to be 2. Now, if it's not written down, then we assume it to be 2. So you'll never see a little 2 written right here, but if there's nothing, it's a 2. Otherwise, you'll see like maybe a 3 or a 5 written in there. It is never 1. The index is never 1. Okay, so you can't have an index of 1. Okay, so I'm going to tell you a little story. So our little story is that we are at someone's house, and we're watching TV, and we're having a little party, a very G-rated party, serving like soda. And at our G-rated party, we are watching a Disney movie, and the Disney movie gets too loud. So the neighbors are upset, and who do they call? They call the police. So the police are coming to our Disney, and they've got their little flashlights and their sticks, and they are coming to our Disney party, and they are mad because our volume is too loud. So when the police come to a party, they're walking up to the party. What does everyone at the party do? Everyone leaves the party. So we are going to talk about how people can leave the party. So when I say who can leave the party, we're saying we have this party and it's G-rated, and people want to leave the party. So for our first example, people can leave the party in groups of 2. Okay, so they can leave the party in groups of 2. And here we are, and because the index is 2. So we don't write that, but remember, if nothing's written, then it's assumed to be 2. So we are going to leave the party in pairs. So if I have 64, that is a pair of 8s. So they get to leave. Okay, 8 gets to leave. Now if I have 8 x's, how many pairs is that? So I have 1, 2, 3, 4, 5, 6, 7, 8. So they're leaving the party in pairs. How many pairs get to leave? 4 pairs. Okay, I have 2 y's, so only 1 pair gets to leave, and 10 z's, so 5 pairs get to leave. So is anyone still at the party? Nope. Everyone made it out. There's our answer. We usually don't put the little 1, so the best answer would be 8, x to the 4th, y, z to the 5th. Okay, so that would be the very best answer. So let's look at some of these down here. So I have 2 x's and 4 y's. So who gets to leave the party? X, y squared. Okay, so there's 1 pair of x's, 2 pair of y's that get to leave. No one is staying. Okay, at any time, remember, you might want to pause the video, see if you can answer one yourself, and then move on. Or make note of any questions that you have as you're watching. Okay, so the next party, I've got the square root of 9, x to the 4th, y to the 6th. So that is 3, and then 2 pairs of x's and 3 pairs of y's. So x squared, y to the 3rd. Okay, so that everyone left that party. Next one, square root of 81 is 9. Very good. Okay, now if I have 12 x's, okay, so they want to leave the party, 12 x's, how many pairs get to leave? 6 pairs. Okay, if I have 2 y's, how many pairs? Only 1. Now, do we write the 1? Usually not. Okay, now last I have 625, and you might need a calculator to take the square root of 625. It turns out to be 25. Now I have 30 x's. So how many pairs is 30 x's? 15 pairs. Okay, then I have 18 y's. 18 y's, they all want to leave the party. How many pairs is 18 y's? 9 pairs. Okay, so that's when everything is even and it all works out. Everyone gets to leave, no one's busted by the cops, everyone's happy. What about when we don't have perfect pairs? So let's take the square root of 20. Okay, the square root of 20 is at a party, and they want to leave. So we break that down to 2, 2, and 5, because 2 times 2 is 4, 4 times 5 is 20. So who gets to leave this party? You're right. This pair of 2's get to leave the party. When those pair of 2's leave, there's one pair, so that's 2, and then the 5 has to stay at the party, because that 5 is going to get busted, because it does not have a partner to leave the party. So these 2's got to leave. There was one pair, so 2 to the 1, the 5 had to stay. Okay, now look at this next one. This next one is going to be an example of a special party, and what groups do they have to be in the special party? They have to be in groups of 3 at this party. So at this party, they can only leave in groups of 3. So when I break this down, I get 27 times 5, and 27 is 3 times 3 times 3. So there's a set of triplets, the 3's. How many sets? One set. So 3 to the times cube root of 5. Okay? Don't forget this little 3 right here has to be in my answer right here. So, okay, for this next problem, I have 36. The square root of 36 is 6. Okay? And then I have 6 x's. So 6 times 6, and then I have 6 x's, and 5 y's. So then I put this in pairs. So that's 1 pair of 6's, 3 pairs of x's, 2 pairs of y's, and then that last y gets busted. It has to stay. Okay? So just to make sure you understand, they leave in pairs, but if someone doesn't have to have a pair, then they have to end up staying in the house. Okay? Staying at the party. So this next one, 10 breaks down to 2 and 5. Are either of those going to have a pair? No, they're not. So does 10 get to leave the party? Nope, 10 does not leave the party. So then I have 10. Now there's one set of 3's that get to leave. The y doesn't get to leave, and the z's get to leave. So I had 3 x's, 1 y, and 2 z's. So 1 pair of x's and 1 pair of y's both got to leave. 1 pair of x's, 1 pair of y's got to leave, but no one else got to leave that party. So 1 x and 1 y had to stay. Okay, now what I want you to do is, the bottom ones are tricky. I want you to look at those for a few minutes. So now it's time to pause. Pause here. Put it on pause. Try those next 4 problems, and then come back to it. Okay? So here we go. Okay, so hopefully you've tried the problems. I'm going to slowly go through them. So 15 is 5 times 5. I have 2 x's, 3 y's, and 5 z's. Put them in groups of 2. Okay, then I get to see who leaves. So I have 1 x, 1 pair of x's, 1 pair of y's, and 2 pair of z's. Then the 15, the y, and the z have to stay. Okay, remember, at the party you can only leave in a group. So the things that don't have a partner don't get to leave. Now look at this next party. These get to once again leave in groups of 3. Has to leave in a group of 3. So my answer is 3pq to the squared. So this is 3, 3, 3, 1, 2, 3 p's, 6 q's. So I need to group them in 3's. So here's a group, here's a group, here's a group, here's a group. So 1 group of 3's, 1 group of p's, 2 groups of q's. That's where this 2 comes from is because there's 2 groups of Q's. This is a 1, this is a 1, because there's 1 group of each one. But we don't write the ones, so it looks like that. Last 2 problems. 2a squared b c squared, and then don't forget to put that 3 in there. So here it is, we're all written out. Okay, and then I match them up in groups of 3. So I'm going to put them in groups of 3. 1 set of 2's, 2 A's, 1 B, 2 C's. Okay. Last one is this very special party, leaves in groups of 4. Okay, so look at this answer. See if you can see where that came from. Okay, so go back and look at anything you need to see again, and be ready to ask questions tomorrow in class, and I'll have plenty of time to answer questions, and then we will take some time to work on the practice from today and the 4-1 practice if you haven't gotten to finish that. Have a great evening.